So good morning, everyone. Now, till now we have seen the CR equation or Cauchy-Riemann equations in Cartesian form. That is, we had x and 1. Now we are going to prove the Cauchy-Riemann equation in the polar form. Now, what are polar form? What are polar coordinates? X and y are called as the Cartesian coordinates. Now, what are polar coordinates? We have done in complex numbers, we have done in double integration, all these things. R and theta, yes, correct. So we have done Cauchy's Riemann equation in Cartesian form, that is in terms of x and y. We had ux is equal to vy and uy is equal to minus vx. Now we are going to get the Cauchy Riemann equation or the CR equations in the polar form. So we know that r and theta are the polar coordinates. Okay, we know that the r and theta are the CR equations in the polar form. So we know z is equal to x plus iy is a complex number in the Cartesian coordinates. So to convert x and y in terms of r and theta, the normal substitution is putting x is equal to r cos theta and y is equal to r sin theta. That is the way we convert from Cartesian coordinates to polar coordinates. Okay, so if z is equal to x plus iy is a complex number in the Cartesian coordinates, then if you put x is equal to r cos theta and y is equal to r sin theta, we get the z in terms of the polar coordinates. So I can write z is equal to, if I replace x by r cos theta and y by r sin theta, we will get r cos theta plus I into r sin theta. So if you take r common, we can write r into cos theta plus I sin theta. And we know that cos theta plus I sin theta is r e raised to I theta. So the polar representation of any complex number is either r into cos theta plus I sin theta or z is equal to r e raised to I theta. So x plus iy is the representation of z in the Cartesian coordinates and z is equal to r e raised to I theta is the representation of a complex number in the polar coordinates. Now we are going to derive the CR equations in polar form. The derivation may not be asked in the exam, but I will show you it's a simple derivation so that you can remember the CR equations easily. So we have started. Now, how did we start improving the CR equation or in getting the CR equations in Cartesian? We started with W equal to f of z. And there we used to put W is equal to u plus iv and z is equal to x plus iy. So here it will be same. W will be equal to u plus iv, but z will not be in terms of x and y. Now we have to replace z in terms of r e raised to I theta. So I can write W is equal to f of r e raised to I theta. Okay? So we are trying to derive the CR equations in polar form. That is in terms of ur, u theta, vr and v theta. Now we know that W is equal to u plus iv. So normally we replace W by u plus iv and z by x plus iy if you have to prove everything in the Cartesian coordinates. Now the change over here is we have to calculate the CR equations in the polar form. So I'm substituting z as r e raised to I theta. So u plus iv becomes f of r e raised to I theta. Now remember the CR equations. Normally we get ux, uy, vx, vy. Now here, since they are in terms of r and theta, we have to get ur, vr and u theta, v theta. So what we will do is we will differentiate equation 1 with respect to r. Differentiating equation 1 with respect to r, we will get, now u derivative with respect to r will become dou u by dou r. Okay, differentiating u partially with respect to r will be dou u by dou r plus I into dou v by dou r, and differentiating the right hand side partially with respect to r. So f derivative will become f dash into the derivative of the bracket term, that will become e raised to I theta because r derivative will become 1. So we are differentiating equation 1, or W equal to f of z only, it's actually, but we are having W equal to f of z in terms of r and theta. So we are differentiating u plus iv equal to f of r e raised to I theta with respect to r first, partially with respect to r. So dou u by dou r, dou v by dou r, differentiating this. So f dash of r e raised to I theta into the derivative of r e raised to I theta is e raised to I theta. Okay, this is equation 2. Next, we will differentiate this equation with respect to theta. We'll differentiate this equation with respect to theta into the derivative of r e raised to I theta. Pages, please mute your mic. Yeah, thank you. So differentiating equation 1 with respect to theta. Differentiating equation 1 with respect to theta, we will get dou u by dou theta plus I into dou v by dou theta. Again, derivative of f will become f dash into the derivative of r e raised to I theta. Derivative of r e raised to I theta is, with respect to theta, will be r is a constant. Derivative of e raised to I theta is I e raised to I theta. So we are differentiating w equal to f of z, or u plus iv is f of r e raised to I theta with respect to r and theta. Okay, we are differentiating equation 1 with respect to r and theta. So we get equations 2 and 3. Now try to use equation 2 and 3 and try to eliminate f dash and e raised to I theta terms. So how to eliminate f dash term from equations 2 and 3? So what we can do is, now in the third equation, we are having f dash of r e raised to I theta into e raised to I theta. So this part can be replaced from the second equation. So we are trying to eliminate f dash of function. So what we will do is, we will substitute f dash of r e raised to I theta into e raised to I theta from equation 2. Okay, so we can write this as, from equations 2 and 3, I will get dou u by dou theta plus I dou v by dou theta. Now instead of this f dash of r e raised to I theta into e raised to I theta, I can replace this part by, so what will remain? IR will remain. So I've taken IR common, and instead of f dash into e raised to I theta, I can replace it by dou u by dou r plus I into dou v by dou r. Okay. So what I'm trying to eliminate f dash of r e raised to I theta into e raised to I theta from equations 2 and 3, or substituting f dash of r e raised to I theta into e raised to I theta from equation 2 in equation 3. Okay, ये जो पार्ट है f dash का जो पार्ट है, that is equal to dou u by dou r plus, तो ये जो पार्ट है, that I am replacing it by dou u by dou r plus I dou v by dou r in the third equation. Okay, so we've got dou u by dou theta plus I dou v by dou theta is IR into dou u by dou r plus I into dou v by dou r. Now equating real and imaginary parts. Equating real and imaginary part. For that, I will take IR inside this bracket. So we can write dou u by dou theta plus I dou v by dou theta is equal to IR dou u by dou r. I into I is I square, but I square is minus 1. So minus r dou v by dou r. Okay. So what we are doing is, we are starting with equation 1, differentiating with respect to r, with respect to theta, and trying to use equation 2, the right hand side of equation 2 in equation 3, so that f dash of r and e raised to terms will get cancelled. We will have only these partial derivatives, and then equating real and imaginary part. So if we equate real and imaginary part, we will get dou u by dou theta is equal to, the real part on the right hand side is minus r dou v by dou r, and dou v by dou theta is R dou U by dou R. This is the, so these are the CR equations in the polar form. So dou U by dou theta is minus R dou V by dou R, and dou V by dou theta is R. Again, I'll tell you how to remember the CR equations in polar form. Before that, so I can write in short, U theta is equal to minus R VR, and V theta is equal to R into UR. Okay. So now we have to try to, we have to actually relate this CR equation with the CR equations in Cartesian coordinates so that you can remember the CR equation. So what we will do is, okay, this is the proof of the CR equation. Okay, so what we are doing is differentiating equation 1 with respect to R, with respect to theta, solving equations 2 and 3, or substituting the right hand side of equation 2 in equation, that is substituting using equation 2 in equation 3, getting this equation, and then equating real and imaginary part, we get the CR equations. Proof they may not ask, but still just remember a small proof, it's not a big one. We can easily solve it also. They may not ask in the exam. I've just shown you. Okay, so next will be, so we have got the CR equation, U theta is minus RVR and V theta is RUR. Okay, so I'll just, how to remember that, same equation I've written. So what was the CR equation in Cartesian coordinates? We had UX is VY, UY is minus VX. So kya karenge? Same format we will remember. Now when U was a function of X and Y, we had pehla X, fir Y or X. X and Y, Y and X with a negative sign. Because YX is opposite, I can say it's a negative sign here. Same way, we have to remember for theta, R and theta. So here the variables are R and theta. So we will start writing with UR. So I will write UR, V theta, U theta, VR. So first R, theta, then R. Again, when you have theta and R, we have a negative sign here also. So the extra term what we get here is 1 by R in UR and minus R in U theta. Only that much you have to remember. Okay. So if I compare the CR equations in Cartesian coordinates and with the CR equations in polar coordinates, in CR equations, how do we write UV here also? So first X, then Y. In second equation, Y and X with a negative sign. Here also UV, R, theta, R. Since we have theta R, we have a negative sign. Extra term what we have is 1 by R and minus R. Okay? So try to remember this way so that you will not make mistake in writing the CR equations in polar form. So what are the CR equations? So I will use this form. UR is 1 by R V theta and U theta is minus R V R. Everything is same. Khali yahan pe 1 by R extra, yahan pe R extra. If you remember the CR equations in Cartesian, then we can write the CR equations in polar form also. Now same way, now from equation 2, what was equation 2? Once again, I will show you that. What was equation 2? Dou U by dou R plus I dou V by dou R is F dash of R. Now what is this R? R we have taken as, Z is taken as R e raised to I theta. So same equation, I will use it here. From equation 2, I can write, now this was e raised to I theta on this side. So I've taken e raised to minus I theta here. So, and this part is equal to Z. So we can write F dash of R e raised to I theta is e raised to minus I theta dou U by dou R plus I dou V by dou R. Or I can write F dash of Z is equal to e raised to minus I theta UR plus IVR. Now what we had in Cartesian coordinate, F dash of Z was UX plus IVX. Now here we have F dash of Z as same UR plus, here also X and X we are having, here also R and R, extra term is e raised to. Okay. So whatever extra term is there, that you remember in the CR equations. Other things you can write if you know the CR equations in the Cartesian coordinates. Okay. So here we have used these two equations in solving the analytic function, in calculating the derivative. Everywhere we have applied the CR equations and F dash of Z. Now when the function is, or when U is given in terms of R and theta, This is the CR equation and this is the derivative f dash of z. Okay, this is the derivative f dash of z. ठीक है? तो कैसे याद रखना है? I told you. You remember one of these CR equations and this f dash of z in Cartesian coordinates, and accordingly we can write the f dash of z in polar coordinates. Okay. So whatever now we have done, हमने क्या क्या किया है Cartesian coordinates में? हमने analytic function f of z निकालना है. There we use Milnor-Thomson method. Then we have applied calculating if u is given, then calculating v. That is a harmonic conjugate. Harmonic function we have seen. Okay. So same concepts here also with respect to the polar coordinates, but not so many problems here. Very few problems are there. So what first thing is you have to remember what are the CR equations in polar coordinates and then f dash of z. Because sometimes some functions are easier to solve with the polar coordinates rather than using x and y. Okay, so sometimes you may have to convert, even though you will be given in terms of x and y, sometimes it becomes easy when you convert those x and y to r and theta and simplify. Okay. So first example. Any doubt in this? CR equations in polar form. फिर derive करके दिखा देंगे थोड़ा समझ में आता है what we have done. The derivation of CR equations in Cartesian is very lengthy. This is not very, so I'll show you here. Theory parts are not normally asked. Okay, so can I go to the next first problem based on these CR equations in polar form and f dash of z. If W is equal to log Z, determine whether W is analytic, and if it is analytic, find dW by dZ or the derivative. If W is equal to f of Z, log Z, determine whether W is analytic, and if it is analytic, calculate its derivative, that is dW by dZ. dW by dZ is same as f dash of Z, because we take W is equal to f of Z, so dW by dZ will become f dash of Z. Okay. So normally what we have to show W is analytic, we show that the CR equations are satisfied. So we normally replace W by U plus IV and Z by X plus IY if it is there in the Cartesian coordinates. That also can be done in this case. So if I replace W by U plus IV, log of and Z by X plus IY, I will get log U plus IV is log of X plus IY. Okay. You can solve this also with X and Y using the real and imaginary part of log of X plus IY. Okay. So what I think I've already shown you in the previous lectures how to get the real and imaginary part. So here, but I will show you with the help of a polar coordinates, it becomes very simple. Because there you have big functions. The real part of this is half log x square plus y square. Then imaginary part is tan inverse of y by x. So big terms you have, then you have wx, uy, vx, vy. But if you make use of the polar coordinates, the functions are not very big. You can easily integrate with respect to r and theta. Okay. So here you can always apply Cartesian form also to calculate ux and vx, uy and vy. But here I will show you using the polar coordinates. So we know that x plus iy in the polar coordinate is r e raised to I theta. If z is x plus iy, I can write z is equal to r e raised to I theta in terms of the polar coordinates. So we will get u plus iv is log of r e raised to I theta. Now log of a into b is log a plus log b. So log of r, that is log r plus log of e raised to I theta. Log and e will get cancelled. We will get I into theta. Okay. So in the formula, actually we had r. R is what? The modulus of this complex number. Theta is the argument. Okay. If you are converting, if you're using the CR equations in the Cartesian form, then you have to write r. R is square root of x square plus y square, and theta is the argument, which is tan inverse of y by x. Okay. So here we are not going to make use of the Cartesian form. We are going to convert this to polar form and use the CR equations in the polar form. Okay. So now equate real and imaginary part. U is equal to log r. V is equal to theta. Okay. If you use the Cartesian coordinates, then we have to substitute r in terms of root of x square plus y square, and theta is tan inverse. So you have big differentiation. Log of x square plus y square ka derivative, tan inverse of y by x ka derivative. But if you convert this to r and theta, the functions are very simple. Log r and I theta. So u is log r, v is theta. So u r kya hoga? U r will become 1 by r. U theta is equal to 0. Here v r is equal to 0 and v theta is equal to 1. We are differentiating u partially with respect to r. That is 1 by r. U differentiating partially with respect to theta. As theta term is not there, u theta is 0. Similarly, since v is theta, differentiating v partially with respect to r. As there is no r term, Vr will become 0. And then differentiating v with respect to theta, we will get v theta is equal to 1. Okay. So this becomes much simpler, the differentiation part here. Now, what are the CR equation? UR is equal to 1 by r v theta. And u theta is equal to minus r Vr. Okay, that has to be checked whether these CR equations are true. So UR should be equal to 1 by r v theta. Is it equal here? UR is 1 by r, and if I multiply v theta by 1 by r, that is also same. Similarly, u theta should be equal to minus r Vr. Here both are equal to 0. So it is equal to, they are equal. U theta is equal to minus r Vr. So the CR equations are satisfied. So we can see the function is analytic. If the function is analytic, we can calculate its derivative. Analytic function का मतलब ही differentiable functions होता है. So calculating the derivative f dash of z. F dash of z in Cartesian coordinates was ux plus ivx. And f dash of z in polar coordinates will be e raised to minus I theta into ur plus I into Vr. Okay? This becomes much simpler in calculating the partial derivatives rather than using the Cartesian form. You can apply any one method. Either you convert this to Cartesian form and then calculate ux, uy, vx, vy, and then use the CR equations in the Cartesian coordinates. But here I've shown you how it becomes simpler when we apply the polar form of that. So some functions we can apply it in the polar form, it becomes simpler compared to the Cartesian form. Okay, so first part is over. That function CR equations are satisfied. Now calculating dw by dz. dw by dz is f dash of z. I told you f dash of z in Cartesian coordinate is ux plus ivx. In the polar coordinate, we have extra term e raised to minus I theta into ur plus I into Vr. Okay, now substituting for ur, we got ur is equal to 1 by r in the previous step. ur is 1 by r and vr we got it as 0. The partial derivatives of u with respect to r is 1 by r and v with respect to r is 0. So we get e raised to minus I theta into 1 by r. Remember dw by dz or f dash of z. The answer has to be in terms of z, not in terms of r and theta. Okay. So हमें आंसर z में लाना है. तो how to convert e raised to minus I theta into 1 by r in terms of z? We know z is equal to r e raised to I theta. तो हमें कैसे लिखना है dw by dz in terms of z? How to get z function? हमें लाना है r e raised to I theta. So r e raised to I theta हम कैसे ला सकते हैं? E raised to minus I theta को हम डिनोमिनेटर में लिखेंगे e raised to I theta. Yes, 1 by z, correct. E raised to minus I theta को हम डिनोमिनेटर में लिखेंगे, तो we will get 1 upon r e raised to I theta. But r e raised to I theta is z, so I can write dw by dz is 1 by z. And we know that the function log z का derivative 1 by z होता है ना? 1 by e raised to I theta into r, that is equal to 1 by z. Yes, correct. ठीक है? So sometimes the functions when converted to polar form becomes easy compared to the Cartesian coordinates. But again, you have the liberty, unless they specify that you have to use CR equations in polar form, you can use any one of the method. So next problem. If W is Z raised to N, determine whether W is analytic and find dW by dZ. Now suppose, now here W is Z raised to N. So if I replace Z by X plus IY, so is it feasible to apply the Cartesian form here? W is equal to X plus IY whole raised to N. It's going to be very difficult to get the real and imaginary part. We have to make use of the expansion of X plus IY whole raised to N, get the real part, imaginary part. That is going to be a tedious work. Instead of that, if we write Z in terms of polar coordinates, then easily we can write the real and imaginary part. Okay, so here if we apply Z as X plus IY, it will become very lengthy, or we will have because we will get in the form of a series. When Z is X plus IY, we will get X plus IY whole raised to N. Then we have to make use of the binomial expansion and write those series, get real part, and N is not known to us. If you have N equal to some number, then we can write, at least we will get a finite. Here also we will get finite, but we don't know what are the terms. So we'll get so many real terms, so many imaginary terms. Instead of that, we will use the polar form of Z, which is r e raised to I theta. Okay. So when you have such type of functions, Cartesian method cannot be applied. So we have to apply only the polar form. So replacing Z by X r e raised to I theta, and W we replace it by U plus IV. So we will get U plus IV is equal to Z के बदले r e raised to I theta whole raised to N. So r e raised to I theta whole raised to N. Now how to get the real and imaginary part on the right hand side? कैसे करना है? We have r e raised to I theta whole raised to n. This is whole raised to n. तो ये n को हमें अंदर लेना है ब्रैकेट के. तो we will get r raised to n e raised to I n theta. Correct. R raised to n e raised to I n theta. Still we cannot write, don't write the real part as r raised to n and imaginary part as n theta. That is not true. Okay. So again we are having e raised to I theta. So write e raised to I theta is cos theta plus I sin theta. So yes, correct. So we can write r raised to n as e raised to I n theta will become cos n theta plus I sin n theta. The real and imaginary part of e raised to I n theta is cos n theta and sin n theta. Now equate real and imaginary part, we will get u and v. Okay, so what we are doing is replacing z by r e raised to I theta. They have not specified that you have to make use of the Cartesian coordinates or the polar coordinates. Okay, so we have to make use of the appropriate method so that the derivative part becomes easy. So here we have not used the Cartesian form of Z. We are applying the polar form so that real and imaginary part can be easily calculated. So we have written W as U plus IV, Z is R e raised to I theta whole raised to N. इसको separate किया है और e raised to I theta का cos theta plus I sin theta use किया है. Okay, now equate real and imaginary part. So we will have U is equal to R raised to N cos N theta and V is equal to R raised to N sin N theta. Equating real and imaginary parts. So U is equal to R raised to N cos N theta and V is equal to R raised to N sin N theta. Calculating or differentiating U and V partially with respect to R and theta. Calculating UR, U theta, VR and V theta. We have to check whether the CR equations are satisfied. So U is equal to R raised to N cos N theta, V is equal to R raised to N sin N theta. So UR क्या होगा? When we differentiate U with respect to R partially, theta will remain as a constant. तो R raised to N का derivative हो जाएगा N R raised to N minus 1 into cos N theta. ठीक है? Similarly, जब U को theta से differentiate करेंगे तो R will remain as a constant. Theta का derivative, cos N theta का derivative is minus N sin N theta. So UR is N R raised to N minus 1 cos N theta and U theta is equal to minus N R raised to N sin N theta. In a similar way, differentiate V partially with respect to R and theta. In a similar way, differentiating V partially with respect to R and theta. So that VR. Again, जब हम V को R से differentiate करेंगे तो theta will remain as a constant. So N R raised to N minus 1 into sin N theta. Similarly, V को theta से differentiate करना है तो R will remain as a constant and sin N theta का derivative is N cos N theta. Now हमें normally हमें opposite ही लेना है ना, UR और V theta and U theta and VR. So UR is equal to 1 by R V theta. Is it so? UR is equal to, अगर मैंने V theta को 1 by R से multiply किया तो दोनों same होता है क्या? Is it so? The first CR equation UR is equal to 1 by R V theta. UR दिया है, V theta यहाँ पे है. Check whether UR is equal to 1 by R. अगर मैंने इसको 1 by R से multiply किया तो we will get N R raised to N minus 1. तो दोनों same हो जाता है. दूसरा कौन सा है? U theta is equal to minus R VR. मतलब अगर मैंने इसको R से multiply किया तो ये दोनों same होना चाहिए with negative sign. That is also true. If I multiply by R, I will get N R raised to N sin N theta. Here also it is true. So both the CR equations are satisfied. ठीक है? Second वाले को हमें 1 by R से multiply करना है and see whether the opposite, ये वाला जो part है, this is equal और इसको R से multiply करने के बाद दोनों equal होना चाहिए but with negative sign. So UR is 1 by R V theta and U theta is minus R VR. So the function, the CR equations are satisfied. Now calculating f dash of z or dw by dz. Calculating f dash of z. That is dw by dz. So for in the polar form, we know f dash of z. In the Cartesian, it is ux plus ivx. In the polar form, we have ur plus ivr. Along with that, we have e raised to minus I theta also. अभी सब्स्टिट्यूट करना है. UR के बदले N R raised to N minus 1 cos N theta और VR के बदले N R raised to N minus 1 sin N theta. Substituting for UR and VR. Substituting for UR and VR. So what will happen when I substitute for UR? So UR याद रखना है R n r raised to n minus 1 cos n theta and n r raised to n minus 1 sin n theta. So we have this dw by dz is ये UR है और ये VR है. Substituting for UR and VR. Take the common terms outside. तो यहाँ पे क्या क्या कॉमन है? n is common, वो बाहर आ जाएगा. R raised to n minus 1 is also common, that also comes out. So I can write n r raised to n minus 1 e raised to minus I theta, तो बचता है cos n theta plus I sin n theta. ठीक है, पहले हमने CR इक्वेशंस प्रूव किया, उसके बाद f dash of z लिखा and then substituting for UR and VR. उसके बाद UR और VR लिखने के बाद जो भी कॉमन टर्म है उसको बाहर ले लिया है. n is common, r raised to n minus 1 is common, and then e raised to minus I theta into cos n theta plus I sin n theta. Then again cos n theta plus I sin n theta, we know it is equal to e raised to I n theta. Why we have to replace? Because हमें फिर से आंसर z में लाना है, मतलब r e raised to I theta कंबाइन करना है हमको. We should combine r and e raised to I theta term in such a way that we can replace r e raised to I theta by z. तो पहले हम क्या करेंगे? cos n theta plus I sin n theta को e raised to में replace करेंगे. तो n r raised to n minus 1, all these are same. Cos n theta plus I sin n theta is e raised to I n theta. Now combine these two. तो मैंने क्या बोला है? r और e raised to theta को combine करना है. Now r का degree is, r का power is n minus 1. So here also you try to bring n minus 1. So take accordingly those terms outside so that you get n minus 1 in the power. Okay. So I can take I common here from these two. If I take I and theta common or I and theta common, so I will get n r raised to n minus 1 e raised to I into n minus 1 into theta. ठीक है, तो माइनस आई निकालने की जरूरत नहीं है. वाई? बिकॉज आर का जो पावर है वो n माइनस 1 है, तो यहाँ पे भी n माइनस 1 ही होना चाहिए. Now we will combine r and e raised to together and raise दोनों को raised to n minus 1 लिख देंगे. तो यहाँ पे लिखेंगे r e raised to I theta whole raised to n minus 1. So that we can replace r e raised to I theta by z. So we will get n z raised to n minus 1. The given function was z raised to n. So derivative of z raised to n is n z raised to n minus 1. Okay, so we have shown that the CR equations are satisfied, and when the CR equations are satisfied, we have calculated f dash of z or dw by dz and got the answer. Remember, the answer has to be in terms of z, not in terms of r and theta or in terms of x and y. It has to be in terms of z only. That is why since we have used the polar form, इसीलिए हम लोग r e raised to I theta combine कर रहे हैं. वहां पे x plus i y combine करना रहता था. When we used the CR equation, when we used the Cartesian coordinates, वहां पे हम लोग x plus i y combine करते थे. यहाँ पे r e raised to I theta combine करना है. So n z raised to n minus 1. Clear? Everything is clear now? Till now what we have done? CR equations in polar form. W को U plus IV पुट करना है, Z को R e raised to I theta पुट करना है, इक्वेट रियल एंड इमेजिनरी पार्ट, U लिखना है, V लिखना है, UR U theta, VR V theta, और फिर अगर इक्वल है तो F dash of Z, अगर इक्वल नहीं है तो we cannot calculate F dash of Z. एनालिटिक है तो ही हम लोग CR this one F dash of Z निकाल सकते हैं. I'm sorry, this is not it's not required. ये गलत हो गया यहाँ पे. Only this is the answer. This part is the गलत हो गया यहाँ पे. Find the value of k if f of z is analytic. F of z is given as r cube cos k theta plus I r raised to k sin 3 theta. Now f of z जो दिया है r और theta में दिया है, तो we have to make use of the CR equations in the polar form. Okay, since f of z is given in terms of r and theta, we have to make use of the CR equation because the function is given as analytic. यहाँ पे function analytic दिया है. अगर function analytic है तो CR equation satisfied होते हैं, but CR equations कौन सा use करना है, that will depend upon the function given. Here the function given is in terms of r and theta. So we have to make use of the CR equations and get the value of k. So f of z is equal to r cube cos k theta plus I r raised to k sin 3 theta. F of z मतलब क्या है, w. F of z is w and we normally replace w by u plus iv. So I'll write u plus iv is equal to r cube cos k theta plus I into r raised to k sin 3 theta. ठीक है, अभी हमें k की वैल्यू निकालनी है इसमें से. For that we are given the condition that function is analytic. If the function is analytic, then the CR equations in polar form are satisfied. So before that, so since to apply the CR equations in polar form, we have to get u and v. So equating real and imaginary part. U is equal to r cube cos k theta, v is equal to r raised to k sin 3 theta. Now calculate UR, U theta, VR and V theta. Differentiating U partially with respect to R and theta and similarly V with respect to R and theta partially. तो UR, सबसे पहले हमें UR निकालना है. तो UR निकालना है मतलब we have to differentiate U partially with respect to R and theta terms will remain constant. तो cos k theta वैसे के वैसे ही रहेगा, खाली r क्यूब का डेरिवेटिव. That will become 3r square cos k theta. वैसे ही u को थीटा से डिफरेंशिएट करना है, तो u थीटा विल बिकम माइनस k r क्यूब sin k theta. cos k theta का डेरिवेटिव is minus k sin k theta. Similarly, VR is equal to k r raised to k minus 1 sin 3 theta and V theta is equal to 3 r raised to k cos 3 theta. है ना? V को r से डिफरेंशिएट करना है तो k r raised to k minus 1 sin 3 theta और फिर V theta मतलब r is a constant, sin 3 theta का डेरिवेटिव is 3 cos 3 theta. So we can apply any one of the CR equations in polar form. So we know that UR is equal to 1 by r V theta. UR is equal to 1 by r V theta. तो इसको 1 by r से मल्टीप्लाई करना है और दोनों को इक्वेट करना है. ठीक है, so we have to multiply V theta by 1 by r. We will get UR ये हो जाता है, V theta को 1 by r से मल्टीप्लाई करना है. Simplify and get the value of k. Tell me what should be the value of k then. K is equal to 3, correct. K is equal to 3. So I will write 3r square cos k theta. This r I can combine, so 1 by r into r raised to k will become r raised to k minus 1. If I compare both the sides, k minus 1 will become 2. यहाँ पे k is equal to 3, यहाँ से भी निकाल सकते हैं, या फिर k minus 1 is equal to 2 and k is equal to 3. यहाँ से भी डायरेक्टली मिल जाता है k is equal to 3 because यहाँ पे cos k theta है, यहाँ पे cos 3 theta है. So k value is equal to 3. If k is equal to 3, then the function will become an analytic function. Using CR equations in polar form, prove that dou square u by dou r square plus 1 by r dou u by dou r plus 1 by r square dou square u by dou theta square equal to 0. बहुत बार रिपीट हुआ क्वेश्चन है ये वाला. Show the previous slide. Okay. Done? Okay. Using CR equations in polar form, prove that. So using CR equations, सबसे पहले हमें CR equation लिखना है. So what are the CR equations in polar form? UR is 1 by R V theta and U theta is minus R VR. पहले उसको हमें लिखना है. क्योंकि हमें बोला है using CR equations in polar form, so we are going to make you a CR equation. So these are the two CR equations in polar form. Okay. Now यहाँ पे जो हमें क्वेश्चन दिया है, यहाँ पे पार्शियल डेरिवेटिव के फॉर्म में दिया है. यहाँ पे हमने शॉर्टकट लिखा हुआ है UR V theta. तो इसको हम लोग यही फॉर्म में फिर से लिख देंगे. तो UR का मतलब होता है dou u by dou r. तो I will write here dou u by dou r is 1 by r dou v by dou theta. Dou u by dou theta is minus r dou v by dou r. Why we are doing? Because to get the answer in this particular form. ठीक है. तो पहले हमने क्या किया है? They have asked to use the CR equations in polar form, so we have made the CR equation, and then these UR V theta and U theta and VR are written in partial derivative form. यहाँ पे शॉर्टकट शॉर्ट फॉर्म में लिखा था हमने, यहाँ पे हमने वो डेरिवेटिव के फॉर्म में लिख दिया. ओके, दिस इज द फर्स्ट पार्ट. ओके, अभी ये इक्वेशन में से हमें ये टर्म्स चाहिए. पहला ये जो dou u by dou r which is already given in the CR equations, ये टर्म हमारे पास ऑलरेडी है. dou u by dou r is 1 by r v theta. वो पार्ट हो गया. अभी हमें चाहिए dou square u by dou r square. मतलब क्या है? इसको और एक बार r से डिफरेंशिएट करना पड़ेगा. We have to differentiate this equation again with respect to r to get dou square u by dou r square. Next we want dou square u by dou theta square. So differentiating this equation again with respect to theta. ठीक है? So we have used the CR equations in polar form. Since we want the second order derivatives with respect to r and theta, ये CR equations को और एक बार dou u by dou r को r से डिफरेंशिएट करना है और dou u by dou theta को theta से डिफरेंशिएट करना है. So what is the derivative of 1 by r dou v by dou theta with respect to r? Now when I write dou v by dou theta, v is a function of r and theta. तो dou v by dou theta कांस्टेंट नहीं है, v is a function of r and theta. तो हमें यहाँ पे u into v अप्लाई करना पड़ेगा, but with respect to r only. v is a function of r and theta, so dou v by dou theta may contain r in that. So it is not going to be a constant. So 1 by r dou v by dou theta को डिफरेंशिएट करना है r से. तो पहले हम क्या करेंगे? 1 by r into derivative of dou v by dou theta. Okay, so I'll just show you in the next slide. This is the first equation. Now we have to differentiate this. हमें क्या करना है, 1/r इंटू डेरिवेटिव ऑफ दिस फंक्शन विथ रिस्पेक्ट टू r. इसको हम लिख सकते हैं डो स्क्वायर v बाय डो r डो थीटा, देन प्लस डो v बाय डो थीटा इंटू डेरिवेटिव ऑफ 1/r विच इज -1/r². यहाँ पे हमने प्रोडक्ट रूल u इंटू वी अप्लाई किया है, u इंटू डेरिवेटिव ऑफ v प्लस v इंटू डेरिवेटिव ऑफ u. This minus sign has come because 1/r derivative is -1/r². ये हो गया सेकेंड इक्वेशन. दिस इज द फर्स्ट CR इक्वेशन, उसका डेरिवेटिव विथ रिस्पेक्ट टू r. नाउ द सेकेंड CR इक्वेशन. द सेकेंड CR इक्वेशन, उसको हमें थीटा से डिफरेंशिएट करना है. When we differentiate this with respect to theta, minus r is a constant. इसका डेरिवेटिव आएगा, it's not a constant because v is a function of r and theta. इसको हम लिखेंगे माइनस r इंटू डो स्क्वायर v बाई डो थीटा डो r. ओके, तो पहले में 1/r is a function of r, डो v बाई डो थीटा is a function of r, इसके लिए u इंटू v किया है. सेकेंड में when we have to differentiate with respect to theta, r is a constant, तो माइनस r वैसे ही रखा है और इसको डिफरेंशिएट किया with respect to theta, तो ये हो जाएगा डो स्क्वायर v बाई डो थीटा डो r. Substitute a, b, c in the given equation and show that the answer is equal to 0. Substituting a, b, c in the equation given, prove that जो दिया है वहां पे लेफ्ट हैंड साइड में अगर पुट करेंगे तो उसका आंसर 0 हो जाएगा. So we have just used the CR equations in polar form. उसको फर्स्ट CR इक्वेशन को और एक बार डिफरेंशिएट किया है r से, और सेकेंड CR इक्वेशन को थीटा से डिफरेंशिएट किया है. दिस सेकेंड CR इक्वेशन, उसको थीटा से डिफरेंशिएट किया है. दिस फर्स्ट CR इक्वेशन, उसको r से डिफरेंशिएट किया है. Now substituting a, b, c in terms in the given equation. Substituting a, b, c in the given equation. यहाँ पे सब्स्टिट्यूट करना, ठीक है. ये तो गिवन इक्वेशन था, तो हमें डो स्क्वायर u बाई डो r स्क्वायर, व्हाट इज डो स्क्वायर u बाई डो r स्क्वायर, दीज टू टर्म्स 1/r डो स्क्वायर v बाई डो r डो थीटा माइनस 1/r स्क्वायर. यहाँ पे ये सब्स्टिट्यूट किया, ठीक है. फर्स्ट टर्म के लिए दो टर्म्स आ गए, डो u बाई डो r, ur is equal to 1/rv. This is from the first CR equation we have got. Then this is dou square u by dou theta square we have substituted. This is from equation, this is A equation, B equation and C equation. Simplify karo, dekho all the terms are getting cancelled or not. So here 1/r dou square v by dou r dou theta minus 1/r square dou v by dou theta प्लस 1/r स्क्वायर डो v बाई डो थीटा, इसको कैंसिल किया तो माइनस 1/r डो स्क्वायर v बाई डो थीटा डो r. तो दीज टू टर्म्स विल गेट कैंसल. These two terms will get cancelled. Plus minus 1/r square and plus 1/r square. Are they same here? यहाँ पे 1/r डो स्क्वायर v बाई डो r डो थीटा है, यहाँ पे minus 1/r डो स्क्वायर v बाई डो थीटा डो r. We know that this is also equal, तो ये भी कैंसिल हो जाएगा and we will get the answer as equal to 0. ठीक है. So this is where use the CR equations in polar form and then got this equation dou square v by dou square u by dou r square plus 1/r dou u by dou r plus 1/r square dou square u by dou theta square is equal to 0. Okay, so this equation dou square u by dou r square plus 1/r dou u by dou r plus 1/r square dou square u by dou theta square equal to 0 is called as a Laplace equation in polar form. Okay, So whatever we have proved equal to 0, this equation is called as the Laplace equation in polar form. हमने Laplace equation in Cartesian भी किया था. What is that? You remember? What is the Laplace equation in Cartesian form in terms of x and y? कुछ याद आ रहा है किसी को? We have not used that Laplace equation as such the name, but in the definition we have said which satisfies the Laplace equation. कौन सा function नहीं याद है? Anybody remembers? Any function satisfying the Laplace equation is called as a any function satisfying the Laplace equation is known as what type of function we say? It is a harmonic function. Any function satisfying the Laplace equation is called as the harmonic function. So this is, so यहाँ पे जो हमने use किया था, this is called as a Laplace equation in Cartesian form. तो हमने इसको harmonic prove करने के लिए we have solved that Laplace, any function satisfying the Laplace equation is called as a harmonic function. तो यहाँ पे भी अगर u is given in terms of r and theta और हमें प्रूव करना है कि u हार्मोनिक है, तो हमें ये वाला लैप्लेस इक्वेशन प्रूव करना होगा. ओके, if y is given in terms of x and y, then we can make use of this function, this derivative. But अगर u is given as function of r and theta, तो हमें प्रूव करना है कि this equation is satisfied to show that u is a harmonic function. So Laplace equation and harmonic function both are same. If u satisfies Laplace equation, u is said to be harmonic. So here also, if u satisfies the harmonic, this is, what is that? Laplace equation, then u is said to be the harmonic function. But यहाँ पे अगर u r और theta में दिया है तो ये equation prove करना है, और अगर u x और y में दिया है तो ये equation prove करना है. Okay, so we'll continue tomorrow with the next type of problems, showing that it's harmonic and showing that finding the analytic function f of z and all those things will continue tomorrow. Okay, so remember this CR equations in polar form as well as this Laplace equation in polar form. Okay, for tomorrow's lecture, we'll be requiring those two again. So dou square u by dou r square plus 1 by r dou u by dou r plus 1 by r square dou square u by dou theta square equal to 0 is the Laplace equation in the polar form. मतलब अगर हमको u हार्मोनिक प्रूव करना है तो ये इक्वेशन इक्वल टू 0 प्रूव करना है, और अगर x और y में प्रूव करना है तो ये इक्वेशन प्रूव करना है. So thank you for today. See you tomorrow. We'll continue same topic. Yes, thank you. Yes, thank you all.